Hello everyone. Can you hear me, please, everyone? Hello everybody. Can you hear me, please? Please, I want more number of students, please, to come in first so that we can start with the lecture. Twelve students have joined so far. Please, what are the rest of the students? Join fast. Okay, right. So we'll start off now with the lecture. Last lecture, if you remember, I was discussing about the reaction with hydrogen of group 16 elements. तो जब ग्रुप 16 एलिमेंट हाइड्रोजन के साथ कंबाइन होता है, इट रिजल्ट्स इन द फॉर्मेशन ऑफ हाइड्राइड्स. ओके, इट रिजल्ट्स इन व्हाट? हाइड्राइड्स. कॉम्बिनेशन विद हाइड्रोजन. अब कितना हाइड्रोजन कंबाइन होगा, रेशियो कैसा है, बहुत सिंपल याद रखने का. ग्रुप 16 एलिमेंट्स का इलेक्ट्रॉनिक कॉन्फ़िगरेशन इज 2s2 and 2p4. So that means 2 electrons short of a stable octet. So therefore, 2 hydrogen will combine. ठीक है? That is one which you need to remember. दूसरा पॉइंट है, and that is कि पहले कौन सा एलिमेंट लिखा जाएगा. Now generally the rule is, exceptional cases are there, but generally the rule is the more electronegative species is written later on. The less electronegative is written before. All right? So that you need to remember. So in this case of group 16, apart from say oxygen and sulfur, the other elements have electronegativity more as compared to that of hydrogen. And therefore oxygen, sulfur, selenium, etc. they are written later on and the hydrogen is written before. Group 17 में भी ऐसा होगा. अभी ग्रुप 17 के एलिमेंट्स भी ज्यादा इलेक्ट्रोनेगेटिव है एज कंपेयर टू हाइड्रोजन. सारे के सारे एलिमेंट्स ज्यादा इलेक्ट्रोनेगेटिव है हाइड्रोजन से, इसलिए ग्रुप 17 एलिमेंट विल बी रिटन लेटर ऑन, हाइड्रोजन विल बी रिटन फर्स्ट. ग्रुप 17 एलिमेंट्स, द वैलेंशियल कॉन्फ़िगरेशन, okay, I just write down the valential configuration, and that is for group 17 the VACC is NH2 and NP. So 2 plus 5 is 7, one short of an octet, and therefore it will combine with one hydrogen. Okay, याद रखिएगा. Okay, for group 15, 16, 17 ये ऐसा thumb rule है, याद रखो ये कि जितना number of electrons are short of the octet, that many number of hydrogen will go into it. In group 15, there are 3 electrons short, so 3 hydrogen, NH3, PH3, okay, all these. Group 16, 2 electrons short of the octet, so H2O, H2S, H2Se. Group 17, 1 electron short, And therefore, we have got various compounds of group 17 combining with hydrogen. So, therefore, we have to say the proportion is 1:1. And therefore, we have compounds like HF, HCl, HBr, and HI. Okay, there is astatine also, but then we are going to ignore astatine. Of course, you know the reason also why? Yes. Okay, it's because of greater electronegativity. Is it like that? No. It's because of greater radioactivity. Okay, greater electronegativity will make it more reactive, so it can easily combine. वो fluorine में होता है ऐसा. लेकिन in case of astatine, it is more radioactive, so its existence is for a lesser period of time, and therefore we say we are going to ignore that reaction. All right, so this is what we consider. So HF, HCl, HBr as well as HI, these are the 4 compounds that we get. Okay, my first question, everybody, is can you read this very well? Okay, fine. Now, we go into the next case, and that is, we start talking about the acidic strength and the hydrogen bonding and thermal stability. 3 points we are going to start. So we begin with, the first is hydrogen bonding. Now you know very well, the strength of hydrogen bonding is directly proportional to electronegativity. Okay, strength of hydrogen bonding is directly proportional to what? Electronegativity. And everybody knows that fluorine is the most electronegative, not only in this group, but in the entire periodic table. All right. So we have HF, HCl, HBr, and HI. From fluorine to iodine, the electronegativity goes on decreasing. Okay, so therefore what we say is the strength of the hydrogen bonding will also decrease. So if I want to go for the strength of the hydrogen bonding, all right, if I want to go into only this, the strength of the hydrogen bonding, then it can be shown this way: HF, the strongest, then comes HCl, then comes HBr, and then the last one is HI. Understood this? Okay, this is what we talk about with respect to the strength. Okay, now if the strength of the bond is more, तो इसका मतलब क्या हुआ? मुझे ज्यादा एनर्जी देना पड़ेगा बॉन्ड को तोड़ने के लिए. ओके, what उसका जो थर्मल स्टेबिलिटी है, that is going to be what? High. Greater the strength of the bond, okay, more the amount of heat which is to be supplied to break the bond. The amount of heat supplied to break the bond is related to thermal stability, directly proportional. So greater the amount of heat supplied to break the bond, greater will be the thermal stability. Okay, so that depends upon what? The strength of the bond as well. So we say the strength of the hydrogen bonding is directly proportional to electronegativity, and also we say it is directly proportional to TS. TS मतलब क्या? थर्मल स्टेबिलिटी. ओके, बॉन्ड स्ट्रेंथ ज्यादा तो थर्मल स्टेबिलिटी ज्यादा. तो बता सकते हैं आप लोग. ओके, आई रिक्वेस्ट ऑल ऑफ यू टू टाइप द आंसर. I don't want a big answers to be typed. Okay, you just tell me whether it is HF, thermally stable highest, ki HI. Who is going to be the highest thermal stability? Come on, tell me. Is it the HF? Ki is it HI? मैं सवाल वापस से दोहराता हूं. HF में हाइड्रोजन बॉन्डिंग सबसे ज्यादा है एज कंपेयर टू HI. ओके, तो बॉन्ड भी वहां पर मजबूत है. तो कहां पर मुझे सबसे ज्यादा एनर्जी देना पड़ेगा बॉन्ड को तोड़ने के लिए? आई एक्सपेक्ट आंसर्स फ्रॉम ऑल ऑफ यू नाउ प्लीज, बिकॉज योर आंसर्स विल बी कंसिडर्ड एज योर अटेंडेंस. Okay, I am saving all your answers and so that I can see the attendance of yours. So please type it very fast. I don't know what exactly in a chemical form, H capital and F capital and all. If it is not possible, you can just simply type, okay, whether it is HF or HI. Come on, please. Okay, so your answer is perfect. So the strength of the hydrogen bonding directly proportional to electronegativity, directly proportional to thermal stability. So this is what is the order of thermal stability. Okay. Next point is, अगर हम बोलते हैं में बॉन्ड सबसे वीक है, when I compare amongst these, याद रखो please. Okay, it's not a universal statement. It's a comparative statement. I'm comparing HI with all these compounds, and I conclude that HI, the bond is going to be what? Very weak. And if the bond is weak, it can break very easily. यानी यहां पर ये बॉन्ड जल्दी टूटेगा. This bond will break very fast, and this will be removed in the form of H plus ions. Okay, and H plus ion is acidic character. A substance donating H plus ion is acid. Everybody knows about this. Okay, so an acid which is donating H plus ions very fast is going to be what? Strong acid. Okay, समझ में आया? वापस से बोलता हूं. In case of HI, आप लोग ने मुझे क्या बोला था? HF में bond is very strong, क्योंकि हाइड्रोजन बॉन्डिंग इज वेरी स्ट्रॉन्ग. इसका मतलब HI में the bond is very weak. Okay, so therefore the bond is very weak, so it will break very fast to give H plus ions. The substance donating H plus ion is an acid. So an acid donating H plus ion very fast is a strong acid. So tell me now, out of these four, all of them are acids, because everywhere the bond is going to break. But can you tell me which one is the strongest acid? HF के HI? मेरा क्वेश्चन समझा आप लोग को? ओके, ये चारों एसिड्स है, ऑल फोर आर एसिड्स, लेकिन सबसे स्ट्रॉन्ग एसिड कौन सा है बताइए? जल्दी से जल्दी H प्लस डोनेट करेगा. कौन है वो? HF है कि HI है? Come on, I expect the answers from everyone if you are understanding the concept. Okay, very good. So the answer is HI. So you are understanding this. So therefore now we go into the strength of acidic character. So that will be HF lesser than HCl, lesser than HBr, and lesser than HI. Okay, this is what happens. Strength of the acidic character will be this. So HI is going to be what? The most acidic, and that is the strongest acid, and HF is the weakest acid amongst these four acids. Okay, याद रखिएगा, amongst these four acids. ठीक है? So this is about the reaction of hydrogen with respect to what? Halogens. Okay, hydrogen with halogen. Okay, first thing you have to remember is the proportion is 1:1 because it's only one electron short. Okay, next thing you need to remember is the strength of the hydrogen bonding. Okay, that is to be very clear. Okay, this is the order of the strength of the hydrogen bonding. This will be the same order for the strength of the thermal stability. And opposite will be the order of what? The strength of the acid. All right. Now, when you consider about the next important point, that is group 18. Okay, so what you have to say is for group 18, they are inert. Okay, and therefore they do not react with hydrogen. stable configuration of NH2 as well as NP6. Okay, it is for what? NH2 as well as NP6 is a stable electronic configuration, a stable octet, neither having a tendency to gain electrons or lose electrons. All right, so that's why it doesn't have any tendency to react with the any species. Okay, so I have given you some examples, and that is with oxygen and fluorine, and that too xenon can react. Okay, I told you this in the last lecture, and we will be discussing this in the later part of the chapter as well. All right, so I hope you have all understood up to this the reaction with hydrogen for group number 17 as well as 18. Come on, please tell me, have you typed a lot? Whether you have understood or not, please let me know. Everyone, please. You can take the screenshot also of this. Okay, probably you must have taken the screenshot, so we move ahead now. Now, my dear friends, we go into the next part. Once we have finished with respect to hydrogen for group 16 as well as group 17, okay, we now go into oxygen. So, action of oxygen. Okay, action of what? Oxygen. So now, first of all is we start with group 16. In group number 16, we have to say that there are two types of oxides formed, EO2 and EO3. Okay, in this case, the E is nothing but oxygen, sulfur, selenium, tellurium. In this case, the E is sulfur, selenium, tellurium. So when you talk about EO2, the first category, and if I talk about E as oxygen, then it gives me O3, which is ozone, and which is a gas. If I take E as sulfur, then it gives me SO2, sulfur dioxide, which is also a gas. If I talk about selenium, it gives you SeO2. If I talk about tellurium, it gives you TeO2. And these two are solids. These two are what? Solids. So you can see there is a variation in terms of physical properties. When it is oxygen, it is ozone, gas, because there are two oxygen already. Plus, if I consider E also as oxygen over here in EO2, in EO3 it doesn't take place, so this is what we get O3. And for this S and T and Se, we all call it as dioxides. Okay, so SO2 and SeO2 and TeO2. Next is when I show its reaction, I need to find out whether it is acidic or whether it is going to be what? Basic in nature. So simply what I need to do is I need is acidic or whether it is basic. And I need to find out its pH value. pH वैल्यू फाइंड आउट करना बहुत आसान है दोस्तों. pH मीटर इजीली अवेलेबल है, तो उसके जरिए हम फाइंड आउट कर सकते हैं. और आयनिक इक्विलिब्रियम में मैंने आपको बताया है कि pH अगर 7 से कम है तो वो एसिडिक है, 7 से ज्यादा है तो वो अबाउट SO2, that is sulfur dioxide. I treat this with water, H2O, it gives me H2SO3. Okay, अगर SeO2 plus H2O करेंगे तो it gives me H2SeO3. ओके दोस्तों, कई बार गड़बड़ ये हो जाता है कि SO2 plus H2O, most of the time the students write down H2SO4, सल्फ्यूरिक एसिड. नहीं, सल्फ्यूरिक एसिड नहीं मिलता, ये H2SO3 मिल रहा है. मतलब इट इज सल्फ्यूरस एसिड. कौन सा एसिड है वो? सल्फ्यूरस एसिड. एंड दिस इज सेलिनस एसिड. ठीक है. नेक्स्ट थिंग इज SO2 का ऑक्सीडेशन टू SO3 ओके हो जाता है आसानी से. एंड देयरफॉर द कन्वर्जन ऑफ SO2 to SO3 is an oxidation reaction. So SO2 undergoes oxidation reaction itself. यानी इसका मतलब क्या हो गया? What does it mean? Okay, अगर खुद का ऑक्सीडेशन हो रहा है तो दूसरे का क्या होगा? Yes, रिडक्शन होगा. और जो दूसरे के साथ होता है वो शब्द एजेंट के पहले आना चाहिए. Okay, and therefore we say that SO2 is a reducing agent. Okay, अभी देखो एक्सट्रीम केसेस कंसीडर करने का. Once again I repeat, SO2 plus O2 gives you SO3. गेन ऑफ ऑक्सीजन है तो SO2 का क्या हो रहा है? ऑक्सीडेशन. अगर खुद का ऑक्सीडेशन होगा तो दूसरे का रिडक्शन होगा. एंड देयरफॉर SO2 is going to be a reducing agent. Okay, therefore SO2 is a reducing agent. Okay, अभी सल्फर का जो एक्सट्रीम में है वो है टेलुरियम. सल्फर इज एट द टॉप ऑफ द टेबल. ओके, एंड टेलुरियम इज एट द बॉटम ऑफ द टेबल. ठीक है. तो अगर SO2 इज अ रिड्यूसिंग एजेंट तो कॉमन सेंस है TeO2 will be a oxidizing agent. Okay, TeO2 will become a oxidizing agent. Understood this part? Okay, so this was with respect to what? EO2. अभी हम EO3 की बात करें. We talk about EO3. SO3 plus H2O gives you H2SO4. अब H2SO4 आएगा. But SO2 plus H2O gives you H2SO3. Okay, ये याद रखिए. This is sulfurous. This is sulfuric. Similarly, SeO3 plus H2O gives you H2SeO4. Okay, selenous acid, this is selenic acid. उसी प्रकार से TeO3 plus H2O, 3 molecules are there, so it gives you H6TeO6. This is telluric acid. This is selenic acid. And this you know is sulfuric acid. Okay, so all of these are acids. देखा आप लोगों ने, ये सारे के सारे क्या है? Acids है. All these are acids. And therefore all these oxides are nothing but what? Acidic oxides. An oxide which when treated in water resulting in the formation of an acidic solution are called as what? Acidic oxides. ओके, और एक और बात बताना चाहता हूं आप लोगों को. ओके, याद रखिएगा ये दिमाग में. एंड दैट इज कि व्हेनेवर अ नॉन मेटल कंबाइंस विद ऑक्सीजन एंड इट गिव्स एन ऑक्साइड, देन इट इज ऑलवेज गोइंग टू बी एसिडिक. ओके, बेसिक तभी होगा व्हेन द मेटल विल कंबाइन विद ऑक्सीजन. वंस अगेन आई रिपीट, व्हेनेवर अ मेटल कंबाइंस विद ऑक्सीजन एंड गिव्स ऑक्साइड्स, that is going to be what? Basic in nature. But whenever a non-metal is going to combine with an oxygen to give an oxide, then it is acidic in nature. Okay, remember this. Okay, it's all because of the difference in electronegativity and all that stuff. Okay, when the time comes in the later part of the chapter, I'll explain you that. But right now, you just need to remember this. Okay, or you just remember in simple words, एक टेक्निक बताता हूँ याद रखने के लिए. BOM. basic oxide of metal. ओके, बॉम्बे का शॉर्ट फॉर्म याद रखो, BOM, बेसिक ऑक्साइड ऑफ मेटल. तो कॉमन सेंस है, फिर बाकी तो आप याद रख ही सकते हो. ओके, कि नॉन मेटल विल बी व्हाट, एसिडिक इन नेचर. क्योंकि कनेक्ट करो, दिस इज द वे यू नीड टू अंडरस्टैंड केमिस्ट्री. कनेक्ट वन कंसेप्ट विथ द अनदर कंसेप्ट. सो डोंट लर्न ऑल द कंसेप्ट्स. एक कंसेप्ट पढ़ो, उस हिसाब से दूसरे को घुमाओ. ये मैं बार बार बोलते आ रहा हूं आप लोग को. Okay, so I hope you have understood up to this. Please tell me, action of oxygen with respect to group 16. Have you understood this? Two types of oxides, EO2 as well as EO3. When you talk about EO2, oxygen will form ozone, it will be gas, sulfur dioxide will be a gas, the rest of them are going to be solids. Next is, the SO2 is going to be a reducing agent, TiO2 will be an oxidizing agent. Next thing is the EO3 part, they are all going to combine with water, giving you acids. So this is sulfurous, this is sulfuric, selenous, selenic, and this is giving telluric acid. And therefore, whether it is EO2 or whether it is EO3, they are acidic oxides. Okay, and how to remember this is BOA, basic oxide of metal. Bolo abhi, has everybody understood this? You can take the screenshot also of this. Okay, so I hope you have taken the screenshot. So the next point, my dear friends, you know very well what am I going to consider. Action of oxygen is already written. Group 16 is done, so we need to write down about group 17. Okay, so now when you talk about group 17, the very first one is fluorine. Okay, and oxygen combining with each other. So what you get is two possibilities, OF2 as well as O2F2. Okay, this is called as difluoride, oxygen difluoride, of course, and this is monofluoride. Now, two important things which I want you to understand over here, and that is the nomenclature, the naming. कंपाउंड का जो नामकरण करना है वो आधारित है जो मोर इलेक्ट्रोनेगेटिव एलिमेंट पर. ओके, यानी इसका मतलब ये हुआ कि जब ऑक्सीजन और फ्लोरीन कंबाइन होंगे तो फ्लोरीन ज्यादा इलेक्ट्रोनेगेटिव है, इसलिए इन कंपाउंड्स को हम ऑक्साइड्स नहीं बोलेंगे. Am I clear with this? जो मैंने ग्रुप 16 में बताया था आपको, सल्फर डाइऑक्साइड, ओके, टेलुरियम ट्राइऑक्साइड, ओके, तो वहां पर क्या था, ऑक्सीजन का इलेक्ट्रोनेगेटिविटी वाज मोर, सो देयर द नेमिंग वाज ऑन द बेसिस ऑफ ऑक्सीजन, तो वी कॉल इट एज ऑक्साइड्स. लेकिन यहाँ पर फ्लोरीन इज द ओनली एलिमेंट, आई बीन ऑलवेज बीन टेलिंग यू फ्रॉम द पास्ट मेनी लेक्चर्स नाउ that fluorine is the only element in the periodic table which is more electronegative than oxygen. So when oxygen and fluorine is going to combine, then I will name it as what? Fluorides. और दूसरी एक बात और याद रखिएगा कि ऑक्सीजन पॉजिटिव चार्ज तभी दिखाएगा जब वो फ्लोरीन के साथ कंबाइन हो, अदरवाइज कभी भी वो पॉजिटिव चार्ज नहीं दिखाएगा जब वो किसी दूसरे एलिमेंट के साथ कंबाइन हो. You understand this one? So as a result of which now stable, okay, as compared to O2F2, okay, because यहाँ पर ऑक्सीजन का चार्ज है +2 और यहाँ पे ऑक्सीजन का चार्ज है +1. एक और बात बता देता हूँ, I use the word mono. Now normally everybody has an impression and that is कि mono मतलब it has to be one. इधर तो 2 है, फिर भी उसको मोनो क्यों बोला है? लेकिन दोस्तों ये 2 है बराबर, ये भी तो देखो, तो आधा नहीं देखने का, दूसरा भी देखने का. ये ऑक्सीजन भी 2 है. Okay, actually it is OF, लेकिन OF cannot exist. So therefore OF ऐसा 2 यूनिट कंबाइन हो जाता है और वो देगा फिर O2F2 and that is डायमेरिक. उसको क्या बोला जाता है? डायमेरिक. ओके, समझ में आई बात? तो एक्चुअली वो मोनोफ्लोराइड ही है, लेकिन सिंगल एज अ सिंगल इट कैनॉट एग्जिस्ट. सो 2 यूनिट्स विल कंबाइन. ओके, इट गिव्स यू अ डाइमर एंड देयरफॉर इट इज O2F2. Okay, so please keep all these things in mind. So, जैसे मैंने बोला है कि thermal stability of OF2 is going to be more. O2F2 and OF2, both of them are very good fluorinating agents. Fluorinating agents मतलब क्या? किसी भी species को convert करना है in the corresponding fluorides, उसको हम लोग क्या बोलेंगे? Fluorinating agent. मैं आपको एग्जाम्पल देता हूँ. न्यूक्लियर फ्यूल नाम तो सुना होगा. ओके, उसमें सब फिशनेबल मटेरियल्स होता है, ज्यादा करके यूरेनियम होता है. उसमें एक और है प्लूटोनियम. ओके, 94 है उसका एटॉमिक नंबर. यूरेनियम का एटॉमिक नंबर इज 92. तो जब प्लूटोनियम होता है उसमें, तो अगर मैंने O2F2 डाल दिया इन अ न्यूक्लियर फ्यूल, आई जस्ट राइट डाउन इन शॉर्ट NF, ओके, जिसमें प्लूटोनियम इज गोइंग टू बी प्रेजेंट. And if I'm going to add this O2F2 in this, it is going to convert this plutonium into PuF6, plutonium hexafluoride. Okay, और इसीलिए मैंने बोला है कि it is going to behave as what? A fluorinating agent. Okay, converting a particular species into the corresponding fluorides is called as a fluorinating agent. ठीक है? So this was with respect to what? The very first element, okay, of group 17, and that is what? Fluorine. हम बात करते हैं अभी नेक्स्ट वन, एंड दैट इज गोइंग टू बी क्लोरीन. विद क्लोरीन इट इज गोइंग टू फॉर्म Cl2O, ClO2, Cl2O6, Cl2O7. Okay, these are the compounds it is going to be forming with chlorine. Okay, various proportions में they are going to exist. Okay, क्लोरीन का ऑक्सीडेशन स्टेट चेंज होते जा रहा है. Okay, आप बोलोगे कि why not so much variation in fluorine? Why so much of variation in chlorine? The reason, my dear friends, is once again very simple. Fluorine के पास d orbital नहीं है. Okay, whereas ऑक्सीजन के क्लोरीन, ब्रोमीन और आयोडीन के पास है. तो जो खाली d ऑर्बिटल से, जो वेकेंट d ऑर्बिटल से, वो यहाँ पर यूज हो रहा है. Alright, and therefore variable oxidation states are possible. Whereas fluorine के केस में मैंने आपको पहले ही बोला था कि please, I'll once again repeat once again. Chlorine can show variable oxidation states. Okay, why it shows variable oxidation state? Because of the presence of d orbitals. Okay, presence of vacant d orbitals. Whereas in case of fluorine, there are no d orbitals present. Okay, and therefore they are going to show this way. Okay, I hope you have understood this up to chlorine. Now we go into the next one, and that is bromine. Br2O, BrO2, BrO3. Okay, these are the 3 forms. Once again I repeat, it is Br2O, BrO2 and BrO3. Okay, these are the 3 forms of oxides which are being formed by bromine. Iodine, I2O4, I2O5 and I2O7. Okay, these are the three oxides with iodine. I2O4, I2O5 and I2O7. Out of which what you have to remember is, from your syllabus point of view, I2O5 is used because it can be asked in the MCQs also, estimation for CO. Now what is the procedure for estimation, quantitative estimation and qualitative estimation? It's not a part of your syllabus, but you need to just remember that I2O5 is used in the estimation of carbon monoxide. So I once again repeat the concepts. Please try to understand that very well. Right now, I am discussing about the reaction of oxygen with group 17 elements. Okay, what am I discussing? The reaction of oxygen with group 17 elements. So, we begin with the first element, that is fluorine. Two types of oxides are formed, OF2 as well as O2F2. That is a difluoride as well as monofluoride. Okay, because fluorine is more electronegative and therefore the nomenclature is based on fluorides. Okay, that is one. Out of which OF2 is more thermally stable, and both of them are good fluorinating agent. And I gave you an example of O2F2 in a nuclear fuel. When plutonium is present, okay, it gets converted into plutonium hexafluoride, that is PuF6. Okay, so that is what fluorinating agent is all about, converting a particular species into its corresponding fluorides. Okay, next, with all the other elements, chlorine, bromine and iodine, various combinations are possible. Everywhere, remember, the charge on the halogens are going to change. The charge on oxygen is fixed, -2. Only the charge on the halogen will go unchanging. Why? I told you. Because the halogen, chlorine, bromine and iodine have vacant d orbitals, and therefore they can be used for bonding purposes. Understood this? Alright? So that you have to remember. I2O5, you need to remember, it is used in the estimation of carbon monoxide, qualitative as well as quantitative. Also, for all these compounds, we call these compounds as oxides. These are fluorides because fluorine is more electronegative. All these are oxides because the oxygen is more electronegative than chlorine, bromine and iodine. Okay, now I guess it's clear. Yeah, Vidhi, it's clear. All right. And then when you talk about group 18, they are generally inert. Okay, group 18 is what? Inert, and does not directly combine with oxygen. Okay, now see here I would like to explain you one important thing, and that is, मैंने आपको बोला था xenon के बारे में. Okay, xenon का size is very large, ionization enthalpy is less, and the d orbitals are going to be what? Vacant d orbitals are going to be present. So xenon can combine with highly electronegative elements, fluorine and oxygen. मैंने बोला था आपको XeF2, XeF4, XeF6, okay, all these. Okay, XeO3, ये भी मैंने बोला था. तो students have a doubt that when I have compound like XeO3 oxides, then why it does not directly combine with oxygen? See, I haven't written. मेरे शब्दों के अर्थ को समझने की कोशिश कीजिएगा, वरना अनर्थ हो जाएगा. मैंने ऐसा नहीं बोला है कि it does not combine with oxygen. What I have used the word, it does not combine directly with oxygen. Okay, yani I have a fluoride first of all, or I have an oxyfluoride, and from that I will prepare oxide. Okay, directly Xe plus O2 gives you XeO3. ऐसा नहीं होगा. It can be formed through fluorides. Okay, so ये मैं आपको बताना चाहता था. Direct combination नहीं होगा. Okay, so I hope this concept is clear. So that's why I've written in group 18, they are inert, does not directly. This word is very important. ये मिस मत करना, otherwise जैसे मैंने बोला आपको अर्थ का अनर्थ हो जाएगा. Does not directly combine with oxygen. Yes, please. Tell me now, have you all understood this? Come on, please let me know. Have you all understood this? You can take the screenshot of this. All right. I hope everybody has taken the screenshot. So we go into the next part. So we are done with the action of hydrogen. We are done with action of oxygen. Now we go into action of halogen. Action of halogens. Halogen, as everybody knows, they have an ability to combine with the other group elements and generally forms what? Halides. So as usual, we need to consider with respect to group 16, 17 as well as 18, because that is what is the title of this particular chapter. So to begin with, we start with group 16. Now when you start with group 16, the various halides which are formed are of the proportion of EX, EX2, EX4, EX, EX2, EX4 and EX6. When I talk about EX, it's a monohalogen. About EX2, that means it is a dihalide. EX4 is a tetrahalide. And EX6 is a hexahalide. Okay, so these are the various combinations. Okay, now you know what is E is and what is X is. Okay, E is nothing but it's a group 16 element. And X, of course, you know, it's a halogen. So we begin with the first of all EX6 category. So when I talk about an EX6 category, the best example which comes in my mind is SF6. It is highly stable. It is what? Highly stable. Next thing is, in this, the E, that is sulfur, undergoes sp3d2 hybridization. Okay, it undergoes sp3d2 hybridization. The geometry is octahedral. Okay, it is what? Octahedral. Next is the order of reactivity. If you want to go into the order of reactivity, so it will be like this: fluorides, chlorides, bromides and iodides. This is the order of reactivity. यानी आपको नहीं समझा तो मैं आपको और क्लियर करके बताता हूं कि फ्लोराइड के पास रिएक्टिविटी सबसे ज्यादा है, और अगर रिएक्टिविटी सबसे ज्यादा है तो इसका मतलब क्या हुआ कि इट कैन बी इन्वॉल्व इन द रिएक्शन इन ग्रेटर प्रोपोर्शन, एंड देयरफॉर whenever I talk about a hexahalide, it is the fluorine which to form that hexahalide. देखो ये फॉर्मूला SF6. You don't have Si6 या SCl6 या SBr6. Okay, very less tendency for chlorine, bromine and iodine to be involved in a reaction in such a large proportion. Okay, क्योंकि उसका reactivity is less. फ्लोरीन का रिएक्टिविटी सबसे ज्यादा होने की वजह से इट कैन फॉर्म व्हाट? हेक्साहालाइड्स. ओके, ये इसका मतलब है. ऑलराइट, सो दिस वाज अबाउट EX6. ओके, वी गो इनटू द नेक्स्ट वन, EX4, दैट इज टेट्राहालाइड्स. सो इन दैट आई विल गिव यू सम एग्जांपल्स. EX4 में एग्जांपल कैन बी SF4, SeF4, TeF4, ऐसा मिलेगा हमें. Okay, SF4 is a gas and all these are solids. Hybridization. Hybridization is always shown by a central element. You know this very well. The entire molecule does not undergo hybridization. So, sulfur, selenium and tellurium is the central atom and they undergo hybridization. And the hybridization is sp3d. Okay, this is the hybridization. Now what happens is, see देखो यहाँ पर hybridization was what? sp3d2. Count the number of orbitals. S, P was 3 and D was 2. So 1 plus 3 plus 2 कितना होता है? 6. Okay, कितना होता है? 6. और सल्फर के आजू बाजू में कितना फ्लोरीन है? 6. So जितने भी ऑर्बिटल्स हाइब्रिडाइजेशन में शामिल है वो सब के सब फ्लोरीन के साथ, उनको हम लोग क्या बोलेंगे? बॉन्ड पेयर ऑफ इलेक्ट्रॉन्स. अंडरस्टूड दिस? ओके, अब नेक्स्ट वाला एग्जांपल देखो. यू सी द केस फॉर द EX4. 4 fluorine are there around the central atom. But if you can see the number of orbitals, S का 1, P का 3, मतलब कितना हुआ? 4, और एक D, मतलब कितना हो गया? 5. Okay, there are 5 orbitals involved in hybridization. लेकिन कितने के साथ बॉन्ड बना रहा है सल्फर या सेलेनियम और टेलुरियम? कितने के साथ बॉन्ड बना रहा है? 4 के साथ. यानी एक ऑर्बिटल है ऐसा जो बॉन्डिंग में शामिल नहीं है, और वो जो इलेक्ट्रॉन्स ऐसे ऑर्बिटल में है that will be called as lone pair of electrons. What will they will be called as? Lone pair of electrons. So all those orbitals which are involved in bonding, then the electrons present in that are called as bond pair of electrons. and the orbital which is not involved in bonding and the electron which is present, that is lone pair affiliate. So I hope you understood how to calculate. Okay, कि कितना लोन पेयर होगा वो आपको शायद समझ में आ गया. This is only on the basis of sigma bonding. Please be very clear. There are pi bonding also, but then let us not discuss or let us not go into the complexities over there. Okay, because we are discussing over here only sigma bonding in this case. समझा आप लोगों को? तो ये याद रखने का कि सेंट्रल एटम के आजू बाजू में कितने और एलिमेंट्स जुड़े हुए हैं, कितने और एटम जुड़े हुए हैं, हाइब्रिडाइजेशन में कितने ऑर्बिटल्स हैं. अगर वो दोनों नंबर मैच हुआ सो नो लोन पेयर. ओके, लेकिन जितना डिफरेंस है उतना लोन पेयर. तो यहां पर इन दिस पर्टिकुलर केस देयर आर 4 atoms surrounding the central atom and there are 5 orbitals. So therefore there will be one lone pair. और ज्योमेट्री हो जाएगा ट्राइगोनल बाइपिरामिडल. Okay, the geometry will be what? Trigonal bipyramidal. All right. We go into the next one. EX4 के बाद अभी जाएंगे हम लोग EX2 पे जाएंगे. EX2. तो उसमें आएगा Cl2, SF2, SeCl2, all these. अब इधर हाइब्रिडाइज एक ऑर्बिटल कम करते जाओ. इधर sp3d2 था, इधर sp3d है, तो इधर से एक और d हटा जाए तो क्या मिलेगा? sp3. अब देखो वापस the total number of orbitals are how many? 4. But if you can consider the number of atoms surrounding the central atom are 2. So कितने का डिफरेंस है? 2 का डिफरेंस है. ओके, 4 ऑर्बिटल्स है हाइब्रिडाइजेशन में और 2 ही एटम है सेंट्रल एटम के आजू बाजू में. तो देयर इज अ डिफरेंस ऑफ 2. 4 minus 2 is 2. So that will be 2 lone pairs. तो यहां पर आपको लिखने का है 2 lone pair. ओके, और ज्योमेट्री आएगा टेट्राहेड्रल. The geometry is what? Tetrahedral. ठीक है? And the last one we have is EX. इसमें I give you the example H2Cl2, S2F2, Se2Cl2. ऐसा है. तो देखो वापस जैसे मैंने आपको पहले भी बोला था कि ये 2 है, हम लोग मोनो हैलाइड बोल रहे हैं, फिर भी ऐसा क्यों? समझ में आया आपको? Because they are all dimeric. Okay, they are all what? Dimeric. And because of the dimeric state, they are going to show this way. यानी मोनोमेरिक में ये क्या आ जाएगा? SCl आएगा या SeCl आएगा. लेकिन मोनोमेरिक स्टेट में वो एग्जिस्ट नहीं कर पा रहा है, इसलिए 2 मोनोमर साथ में आ जाएंगे and it results in the formation of what? A dimer. Okay, it results in the formation of what? A dimer. So that is what we need to consider. All right, so S2Cl2, S2F2, Se2Cl2, all right, they are all going to be in what? The dimeric state. Also, let me be very clear with one point, and that is when I talk about Se2Cl2, it gets converted into SeCl4 and Se. अब ये रिएक्शन आप देख सकते हो दोस्तों. Se2Cl2 giving SeCl4 plus Se. Chlorine will have a charge of -1. Okay, once again I repeat, chlorine will have a charge of what? -1. Okay, दिख रहा है यहां तक आप लोग को? Everybody understanding this? Se2Cl2 is giving what? SeCl4 plus Se. Can you see this last reaction? Everyone, can you see this last reaction? Everyone, please tell me. मैंने आप लोग को बोला है फुल स्क्रीन पे देखो. See this video in a full screen. Otherwise आपको हाफ बोर्ड दिखेगा. Okay. So Se2Cl2 giving SeCl4 plus Se. क्लोरीन का चार्ज है -1. Alright. So -1 into -1 means it gives you what? -2. तो ये Se2 में क्या आ जाएगा? +2 आएगा. ओके, अब +2 आएगा, लेकिन हमें चार्ज हमेशा एक ही स्पीशीज का बताने का है. तो अगर एक ही स्पीशीज का चार्ज बताएंगे तो क्या हो जाएगा? +2 को 2 से डिवाइड करो. ओके, क्योंकि यहाँ पे 2 ऐसी है सो इसका मतलब एक AC के ऊपर चार्ज कितना आएगा? +1. ओके, 1 AC will have a charge of what? +1. अभी देखो यहां पर कम हो गई है. सेम कंसेप्ट वंस अगेन. Every chlorine has a charge of -1. तो 4 chlorine will have a charge of -4. तो सेलेनियम के ऊपर चार्ज कितना आएगा? +4. ओके, यहां पर देखो, when you go into this AC, ओके, दिस AC अलोन है, इट्स नॉट इन अ कंबाइंड स्टेट. और एक बात याद रखिएगा, कोई भी एलिमेंट हो पीरियोडिक टेबल में, एनी एलिमेंट इन द पीरियोडिक टेबल, when it is alone, when it is not combining with any species, then remember its charge is 0. Okay, when it is not combining with any species, so that means its charge is going to be what? 0. Understood this? So यहाँ पर 0 आएगा. Okay, अब देखो, AC is +1. Now there are two ways. Have a look at it. First, ये रेड कलर में दिखा रहा हूं आपको, AC +1 to AC +4. नेक्स्ट, ये ब्लू कलर में दिखा रहा हूं आपको मैं, AC once again with AC only. Okay, I hope you can identify the red and the blue lines. If you can see the red line, +1 से +4 हुआ है. Okay, +1 से +4 हुआ है. चार्ज बड़ा है. चार्ज बड़ा मतलब it is oxidation. Okay, it is oxidation. यहां पे अभी ब्लू लाइन देखो, +1 से 0, चार्ज कम हो गया है, and that is called as reduction. समझ में आया? वापस से एक्सप्लेन करता हूं. If you have not understood, I will once again explain you. Listen to it very carefully. AC has a charge of +1. यहाँ पर in products also it has formed AC, one in the +4 state and the other in the 0 state. So from +1, if you see the red line, it goes to +4. So +1 to +4, charge increases and it is called as oxidation. From +1 of selenium, it goes to 0. The charge decreases and that is nothing but what? Reduction. So oxidation किसका हुआ है? सेलेनियम का. Reduction किसका हुआ है? सेलेनियम का. So the same species is undergoing oxidation as well as reduction. वापस से बोलते लीजिए अच्छी तरीके से. The same species is undergoing oxidation as well as reduction. And this is known as disproportionation. मैं लिख के देता हूं. This is known as what? Disproportionation. I write it down over here. बोलेंगे इसको disproportionation. नॉर्मली आप लोग कौन सा वर्ड यूज करते हो? रेडॉक्स. ओके, ऑक्सीडेशन रिडक्शन टेकिंग प्लेस इन अ रिएक्शन इज कॉल्ड एज अ रेडॉक्स रिएक्शन. लेकिन दोस्तों, रेडॉक्स और डिस्प्रपोर्शनेशन में अंतर है. ओके, दोनों में ऑक्सीडेशन और रिडक्शन हो रहा है, लेकिन जब हम रेडॉक्स रिएक्शन की बात करते हैं तो इन दैट केस व्हाट वी से इज द स्पीशीज अंडरगोइंग ऑक्सीडेशन एंड द स्पीशीज अंडरगोइंग रिडक्शन आर डिफरेंट, दो दे आर ऑफ द सेम रिएक्शन. लेकिन यहां पर द स्पीशीज अंडरगोइंग ऑक्सीडेशन एंड रिडक्शन आर सेम. द सेम स्पीशीज is undergoing oxidation as well as reduction, and therefore this is called as disproportionation. Okay, तो वापस से बोलता हूं मैं, सुन लीजिए अच्छी तरीके से. Okay, and that is disproportionation and redox. Redox में oxidation and reduction are taking place of two different species in the same reaction. In a disproportionation, the oxidation and reduction is taking place of the same species. बोलो दोस्तों, क्या आपको समझ में आया ये? Have you all understood this very well? The difference between disproportionation and redox reaction? Bataiye please. Have you all understood the difference between disproportionation and redox? Come on, please answer my question. Come on, please. I'm waiting for the answers from all of you. Have you all understood? Okay. Now please take the screenshot of this. All right, done, I guess. Okay. Now we talk about group 17. Question will be now, you will say group 17 itself are called as halogens. और यहाँ पे ऊपर भी लिखा है एक्शन ऑफ हैलोजन. तो कुछ समझ में नहीं आया. What is all this? Yes, it is right. Halogens do combine with the other halogens. मतलब fluorine, chlorine, bromine and iodine. Okay. To talk about fluorine, it is going to combine with the another halogen. One particular halogen is going to combine with another halogen, thereby resulting in the formation of compounds, and that is called as interhalogen. Other hai, इसलिए inter. Different is inter. Same है तो intra. Alright. So they are going to form compounds which are called as what? Interhalogens. Yani, if I say F2 is an interhalogen, no ways. Okay, क्योंकि यहाँ पर तो सेम हालोजन कंबाइन हुआ एक दूसरे के साथ, तो वो इंटरहालोजन नहीं है. ओके, इंटर का मतलब होता है डिफरेंट. So there are 4 types in this. Just the basics I would like you to understand at the moment. Okay, and then the detailed part of this we are going to discuss towards the end of this particular chapter. So the types are 4 types. First is XX dash, XX dash 3, XX dash 5 and XX dash 7. Okay, X और X सिंपल मैंने सेम रखा लेकिन X dash लिखा है यहाँ पर. Okay, ये ऐसा लिखा होता तो it is like this, fluorine. Okay, लेकिन ये X dash है. So that means that both of them are halogens but they are different ones. ठीक है, ये इसका मतलब निकलता है. Now when you consider with respect to the atomic size, दोनों halogens अलग-अलग है, so properties will be different. So when you talk about comparison between X and X dash, so the atomic size of X is going to be greater than X dash. Okay, ये याद रखिएगा. और जब इलेक्ट्रोनेगेटिविटी की बात करते हैं तो it is this way. X dash is going to be greater than X because atomic size and electronegativity are opposite. Am I clear? And therefore, एक बात मैं आपको बताना चाहता हूं अभी, and that is fluorine will be always in the form of X dash. क्योंकि उसका इलेक्ट्रोनेगेटिविटी इज ऑलवेज हाईएस्ट, हमेशा हाईएस्ट है। यानी जब भी फ्लोरीन इंटर हैलोजन कंपाउंड बनाएगा तो हमेशा याद रखेगा इट विल बिहेव एज व्हाट एक्स डैश। ओके, और आप देख सकते हो, forget about this one, okay, but then if you see the other ones, x dash का proportion is more than x because fluorine is more reactive and therefore it will be involved in the reaction in a greater proportion. Alright, इसलिए ये बात आपको याद रखनी है. More details will be discussed with you in the later part of the chapter. ओके, यहां पर आपको इतना याद रखने का कि halogen, one particular halogen is going to combine with the another halogen, resulting in the formation of interhalogens. Their proportion of combinations are different, and therefore we have 4 different types of interhalogen compounds, and these are the ones, and then these are the criteria for the atomic size as well as electronegativity. Okay, now coming to the last point. Okay, and we'll wind up with today's lecture also, and that is group 18. Now in group 18, xenon can combine with halogens. Okay, and the reaction will be like Xe plus F2. The temperature is going to be around say 673 to 683 Kelvin at say 1 atmosphere pressure, and it is resulting in the formation of XeF2. Okay, अभी अगर मैंने proportion of Xe और F और ये conditions मैंने change किया, then I can have compounds like XeF4, I can have compounds like XeF6. Okay, I have compounds like this. मैंने आपको बोला था, if you can remember in my previous lectures, कि xenon is the largest atomic size inert gas element in group 18. Xenon के बाद radon होता है, but then it is radioactive, so that's why we don't consider it. तो पहला तो उसका atomic size is largest amongst the inert gases, दूसरा उसका ionization enthalpy is less, और तीसरा absence of vacant d orbitals. तो ये 3 reasons, I'm very sorry, presence of vacant d orbitals. In the other elements it's absence of d orbitals, लेकिन यहाँ पर it is a presence of vacant d orbitals. तो ये जो 3 reasons है, atomic size highest, ionization enthalpy lowest, and presence of vacant d orbitals, xenon do form compounds. तो यहाँ पे वो फ्लोरीन के साथ कंबाइन होगा, because we are talking about with respect to halogen. So it combines with fluorine in various proportions by volume, because xenon is a gas, fluorine is a gas. It can combine to give you various compounds. Okay, so यहाँ पर it is XeF2. It can be also XeF4. It can be also XeF6. So difluoride, tetrafluoride, hexafluoride can be formed depending upon the conditions and the proportions. Okay, so in group 18, only this is what you need to write down: halogens. Okay, so with this, we finish with the topic of action of halogens with respect to group 16, 17, and 18. Okay, so I completed with this action of hydrogen, action of oxygen, and action of halogens. Okay, of group 16, 17, as well as 18. For 18, it is very simple. Does not directly combine with hydrogen as well as oxygen, but with halogen, you can give the example of xenon. Okay, so more you need to discuss only with respect to what? The group 16 as well as group 17. All right, so I hope you have understood these concepts very well. Please, okay, reply in your comments. Have you understood or not? Yes or not? Please comment, everyone, and take the screenshot also of this. Please, I want everybody to put your comments, please, whether you have understood or not. So I hope you have taken the screenshots also of this. All right, so now that's it then for today's lecture. Okay, I stop over here. I thank you very much for joining me, and I'll see you later. Okay, till then, take care, everyone. Bye bye.